So here on question 10 in the Unit 6 example set, you are given a function, p of x equals 1 over x squared minus x minus 12. And then asked several questions. Are they true? Are they false? First, let me just assure you that on the test, you will be given multiple choice. And actually, you will be given Roman numerals that have different characteristics or possible characteristics of this function. And then you will be asked to decide which ones apply, and then you select the answer that has those. So it's a little bit different than this, but because on the review, we like things to be free response instead of multiple choice because that challenges you more. This is how we've set it up. The other thing is on your review, this bottom part should have been factored. I believe this factors to x minus 4 and x plus 3. I should have done that on my own, and I didn't. I don't know why I didn't, but I didn't. So there we go. Let's see if we can answer these things. First one, Roman numeral 1. There is no y-intercept. Well, I'm going to disagree. If I stick in 0 for those x's, I get 1 over 0 minus 4 times 0 plus 3, which reduces or simplifies to 1 over negative 4 times 3, which is negative 1/12. That's a negative. This is an equals. It kind of got blended in there. Anyway, that's very definitely a y-intercept. It's not undefined. So is there no y-intercept? We know that's not true because we just found one. There's a horizontal asymptote at y equals 0. Well, to do that, we need to figure out what the degree of the top is and what the degree of the bottom is. We've been doing that by multiplying stuff on the top and the bottom. In this case, the only thing on the top is a 1. And then on the bottom, we would multiply x and x, which gives me x squared. So I would compare the biggest exponent of a variable on the top to the biggest exponent of a variable on the bottom. And the truth is, the only way that we would have an x up here if it was x to the 0, which is a little confusing. So let me explain it more like this. There is not one up top, but there's one on the bottom. That means the bottom is definitely bigger, which means the horizontal asymptote is y equals 0, which means this is true. There's an x-intercept at 1, 0. I can tell you that is straight up false. What you're supposed to do is get rid of the hole. There are no holes. So once you know, sorry, I stopped being able to speak English for a second. Once you can show or have removed any holes, so you're left with an expression that has no holes in it, you're supposed to look at what's left on top. Well, all I have is a 1. I can't set that equal to 0 because that would be a false statement. There's no x to solve for, so there's nothing here to solve for an x-intercept, which means there isn't one, so this would be false. There's a vertical asymptote at x equals negative 3. Well, I don't know. To find that, I would look at this. I would remove the holes. There's no hole. Then I would take what's left on the bottom and set them equal to 0. So I would take x minus 4 and set it equal to 0 and solve by adding 4 to both sides. That's x equals 4. And then I would take x plus 3 and set it equal to 0. And I would solve that by subtracting 3 from both sides. I get x equals negative 3. So my vertical asymptotes are x equals 4 and x equals negative 3. There's a vertical asymptote at x equals negative 3. Absolutely, that's true. And then lastly, it asks if the range is all real numbers. Now, we've talked about domain and range, and what we've said is they want to be all real numbers really, really, really bad. But they can't be because there's always going to be one or two places where things are undefined. All right? For the domain, that will be the vertical asymptote and the hole. Those places, vertical asymptotes and holes, there could be more than one. So those places are not included in the domain, which means it's not quite all real numbers. For the range, it's the horizontal asymptote. Now, if we didn't have a horizontal asymptote, then we might be able to say the range is all real numbers. But we looked back up here, and we know that there's a horizontal asymptote at y equals 0. So the only number not included in the range is 0. Unfortunately, that still means that it's not all real numbers. So this is false.